Yeah, hello all. Welcome to this presentation on my project for the human factors in AI course. The topic is augmented orthopedic disease detection via ML-driven X-ray scan analysis. So as you can notice, it's an augmented approach where we will augment the human doctor and not try to replace him by automation. So it's something that will give suggestions to the human doctor. We will follow the agenda of task analysis, user experience design, privacy considerations, and ethical considerations. In task analysis, so what's the problem? The problem is many doctors who are not sufficiently experienced, especially those working in rural areas. So when they look at X-ray scans of the orthopedic patients, sometimes they are not confident of what is the diagnosis of this disease, and they feel the need for a second opinion. Now, if that second opinion needs to be taken from an expert doctor who is probably in some urban area, who's likely very busy, who charges a lot of fees for his consultation, then for a rural patient, it becomes a bottleneck that the consultation will now be referred to an urban doctor. The scan will be sent over email. He will respond. He will charge a higher fee. So this becomes a bottleneck because the rural doctor is not confident enough. He wants a second opinion from a more experienced doctor, and that's a bottleneck. So that's the problem which we have identified and which we are trying to solve. So the target user of our ML solution is the less experienced doctors, especially in the rural areas, who feel the need for second opinion on analyzing the X-ray scans from their orthopedic patients. How this approach will work is the patient X-ray scan will be digitized and it will be given both to the human doctor and also to the ML-driven analysis solution. And both the human doctor will come up with his diagnosis and the ML-driven solution will come up with its diagnosis. If the human doctor agrees with the ML-driven solution diagnosis, then the diagnosis is finalized because both parties agree, the human doctor and the ML model, and affirmative feedback will be given to the ML model that your diagnosis was correct, and the patient will be informed of the diagnosis and the treatment. The treatment will be decided by the doctor. But if the human doctor and the ML-driven suggestion do not match, then in that case, the human doctor will refer to an expert doctor because now there is no other option than to go to the expert doctor who could be in the urban area. And then the expert doctor will decide whether the human doctor is right or the ML model is right, or maybe a third diagnosis is right. And if the expert doctor agrees with the ML solution diagnosis, then it will give affirmative feedback to the ML solution that you're right. If he disagrees with the ML model analysis, then he will give a correctional feedback to the ML model for retraining and correcting the algorithm. Now, point to note is here also we may need to go to the expert doctor, but the frequency gets reduced because very often, even though the human doctor is not confident, if his diagnosis and the ML solution diagnosis agree, then the diagnosis is finalized. Then there is no need to go to the expert doctor. So the frequency or proportion with which we may need to consult the expert doctor will get reduced, and that is the objective because the expert doctor in the urban area is going to be expensive, he's going to be busy, and that's the bottleneck. So the solution is the human doctor in the rural area will leverage the ML driven solution to decide on the diagnosis in most cases. Now, what is the user experience design like? So for training, firstly, we need to do the training. For training, we will provide digitized versions of the patient's X-rays to experienced doctors because the training dataset labeling anyway has to be done by an experienced doctor. It cannot be done by less experienced or a novice kind of a doctor. So the training dataset labeling will be done by the most experienced doctors, and they will be given a dataset of X-ray scans which they will label and classify into the following categories, like whether it's bone fracture, bone infection, joint dislocation, arthritis, bone cancer, or no disease. And the doctors will also specify the region of interest in the complete X-ray scan, which region indicates the disease. So the X-ray scan could be a big thing, but within that, this is the region which is actually giving me what the disease is. So that region of interest will also be marked by the doctors in the training data set. Then for inferencing, each patient scan who comes to visit the less experienced doctor will be scanned through the ML driven model which gets developed, and it will also give the classification of probabilities and also show the region of interest from where it inferences the disease which is present. And finally, there will be correctional feedback also. We will look at correctional feedback in the subsequent slide. So how will we ensure transparency in the data set? So the data set which is used for training, we will mention from where the library of the anonymized X-ray scans was obtained. So firstly, the library will be anonymized, and we will mention from where the library of X-ray scans were obtained, whether from a public library or from a paid source, etc. And we will mention who were the expert doctors who labeled the training data set so that there is complete transparency. Now for inferencing, we will use the CNN based approach, which is a deep learning approach. So it will not be possible to tell patients what attributes and what weightages were used for the final decision, because in CNN and deep learning models, it's not possible to explain the model to the third party. So that drawback will be there because you can't work around that. But the ML output will show the region of interest, that even though I can't explain the attributes and their weightages, but this is the region of interest from where the disease was identified. Next, communicating uncertainty. So it will not just give final classification, it will give probabilities of each class of possible outcome. So a typical outcome, not always, but a typical outcome could be I give an X-ray scan and it gives an output that bone fracture is 50% probable, bone infection is 15% probable, joint dislocation is 25% probable, arthritis is 5%, bone cancer 4%, no disease is 1%. So the human doctor can see it's most likely bone fracture at 50%, but it could also be joint dislocation. So the doctor will then look at the region of interest and scan from the possibility of bone fracture and joint dislocation. And if he agrees, he will give affirmative feedback that I agree with your analysis that it is indeed bone fracture and there was possibility of joint dislocation, but finally it's bone fracture. So I agree with your highest classification probability of bone fracture. It is indeed a case of bone fracture. So affirmative feedback will be given to the model. But if the doctor does not agree with the classification, then he will refer it to an expert doctor whose opinion will then be final. And if the expert doctor agrees with the ML model output, he will give affirmative feedback to the ML model. If he disagrees with the ML model output, then he will give correctional feedback to the ML model. So in this way, there will be explicit feedback given by either the original doctor or the expert doctor to the ML solution. Then the applicable privacy law will be HIPAA because it deals with personal medical data for the patients. The training data set will be fully anonymized. So in the training data set, it will just be a series of X-ray scans without any information of the patient's name. Only their gender information will be there. That for this patient, this is the gender, this is the X-ray scan. And then the labeling will be done by the expert doctors on those fully anonymized data set. That anonymized data set will be purchased either from an already HIPAA compliant data set provider. For example, there could be commercial entities who say we already are HIPAA compliant and this data set is available with us for you purchase it. It is already in compliance with HIPAA. So nothing to worry about. But if such a thing is not possible and we need to collect our own data set from some hospital, then we will seek permission from the patients whose X-ray scans are being used for the training data set and the subsequent labeling. And we will provide the full disclosure on the purpose of the ML model for the patients whose scans are being used for the training data set. Then when it comes to inferencing data set, which will come from the patients who are coming to the doctors for diagnosis of their orthopedic diseases, we will ask them to sign up a consent form, which will carry consent approval that their X-ray scans will obviously be seen by the doctor, but will also be analyzed via an ML model. There will be privacy policy associated with the consent form. It will mention what is the duration for which the X-ray scan and the ML driven analysis is going to be retained in the database. And yet the patient will also have the option to delete his scan at any point of time, that just do the diagnosis, tell me what is the final output and delete the scan. So that option will also be there with the patients. And then recourse methodology will also be there. If patient feels for some reason he signed the consent form, but somehow he feels now the data is being misused or is being sold to somebody else, then there will be a recourse methodology that you can complain to this consumer court if you think there is misuse of your data. Then the final section on ethical AI, the source of bias. There will be three sources of bias: historical bias, representational bias and learning bias. So historical bias will arise because finally for the training data set, doctors, human doctors are labeling the data set, even though they are experts who are labeling the training data set, but they could also have some wrong perceptions or wrong lack of absolute understanding. So even the perfect best doctor could only be 99% accurate. So some errors will naturally creep in. Errors or bias will naturally creep in because even the expert doctors will not be 100% accurate in their diagnosis. And we will remedy it by leveraging the best doctors we have available for labeling the training data set. Plus we may employ multiple doctors to label the data set and see if they agree in the labeling process. Then there could be representational bias, because what happens is males or men are more likely to engage in activities which can cause fracture, joint dislocations, such as adventure sports, driving, paragliding, sailing, etc. And that's why in the training data set, if we take a data set of say 1000 X-ray scans, it could be that 700 of them are from men or males and only 300 are from females. So what we will try to do is, in the training data set, we'll try to see that there is 50% of scans from males and 50% of females, so that representational bias is not there. Then learning bias could also be there. Now what happens is, people come for X-ray scans only when there is something wrong with them. A healthy person will not visit an X-ray center and say, take my X-ray scan. So the no disease scenario will probably not be there in the training data set, because a healthy person will not go to an X-ray center and get his entire body scanned by X-ray, because there are drawbacks to getting X-ray done on your body. So no disease scenario may be underrepresented in our training data set. So what we will try to do is make sure that there are sufficient number of no disease scenario also represented in the training data set, so that this learning bias is not there for the ML model. Then the goals of ethical AI. So the goal of fairness will be achieved because only gender data will be retained in the training data set. Other aspects such as race, religion, etc. will not be retained in either the training data set or the inferencing data set. And all the steps we mentioned in the previous slide for eliminating the bias will also ensure that the goal of fairness is achieved. Now, accountability. The point to note is, ML model will only provide suggestive output to the human doctor, and finally the human doctor, the original doctor or the expert doctor, will provide the final diagnosis and the judgment. So accountability will finally be on the human doctor who is delivering the diagnosis to the patient, yet the patient has the option to know that an ML model was being used as a suggestive approach, and this company developed the ML model and this was the training methodology used. And that also comes part of the transparency approach, that the patient will have the option of knowing that an ML model is being used to provide the suggestion. And if he wants, he can see the X-ray scan with the region of interest marked on it, even though how or which attributes were used will not be conveyed to him, but he can see the X-ray scan that this is the X-ray scan which was analyzed by the doctor. This is the region of interest which was identified by the ML model. And finally, the human doctor took the final decision based on his judgment, and he will have complete view of the process. And so transparency is not fully required from the ML model because it's only giving a suggestion, and it is finally the human doctor who is delivering the judgment. But the patient will know that this is the entire process which was followed. And in that sense, the transparency aspect will be met. So that was the complete presentation. Thank you for watching.